All right, so I'm starting some sound up here. Hopefully, you guys can hear me. Um, I was just drawing on the tablet like 2 seconds ago, and I lost my pen for that, which will mean that I'll have to change the way I. Oh, found it. Found it, guys. Thanks. Sorry, I had my sons looking for it. I went to grab a cup of coffee and thought I had lost my pen here. So, what I'm going to start with here is a look at um, where everything's at and what's going on. So I'm going to pull up the web browser here. Now notice this is a little bit meta here, as this is a picture of the picture at the time. Oops. Let me get my web browser back up. There we go. There we go. And so here is the picture of the web browser and the live stream. What I want to do is I want to come over here and I want to look at Blackboard. And specifically, I'm just going to pick one of the classes. I'm going to pick one of the classes to look at. And so I'm going to look at the first section here. And what you'll notice is that I'm doing links in the lecture announcements. Now, these links I have to create the day of the class. So I'm going to be doing the live class on the time that we had class, but I'm very, very much aware that everyone's schedules are up in the air. So I'm not requiring you to be in the lecture. The requirement is that we look at the material and move through the material with a timeline. And so I put an update. Pearson was having some problems yesterday, and I got an email from Pearson, so I put that through on the announcements on Blackboard. And I also talked about the review answers. So what I want to notice here is in course content, you're going to see I'm going to be doing in pairs of chapters all the due dates in the videos as they come through. So we have finished chapters 3 and 4. And what is on, you'll see this as a page of links, is there are the videos that I've recorded and the links to them. And then there are two what would have been in class worksheets. The one I handed to you beforehand, and I went and I recreated that in an online version. Now notice though they're due April 5th, and I have worked out an example problem using the numbers that are on mine. Now Pearson gives random numbers each time, so you go into quiz, what would be quiz for chapter 3, you'll get different numbers than mine. But I've worked out an example of all of these. And I'm using the two calculators, the TI-30 and 30XXIIS and the TI-84. Now the camera I have right now is not focusing well on the TI-84 screen. It focuses really well on the TI-30 screen. I think part of it is the light I have overhead here. So I'm playing with some things to get that a little bit visual. So I will write out the keys and the different things to do. Now I will be finishing tonight the chapter 4 example problems, and I'll be putting them under here. And so this one page will have a list of where you can get all the videos and what's due for chapters 3 and 4. And notice here, the actual online exam will be due April 12th, and that will be posted tonight also, and you can take that at any time. Actually, I'll probably say tomorrow, because I'll get the other videos up first, and the videos take a little bit to record, but not much. Like this section here didn't take too long to record, coming across, and the stuff for chapter 4 takes a little bit longer. Then in the online exam itself on chapters 3 and 4 will be due April 12th. That is that material there. So let me go back to my main page here. Let me see if anyone's saying anything there. All right. And what I wanted to show you was on the YouTube page itself. Don't mind my crazy content. We'll come down here, and I have a shortcut to all of my MWCC class material, which I will come here, MWCC classes. I'll make a shortcut for that, so I'll copy that. And what I'll do is I'll come back here, come back to course content, and I will put a short page, blank page, link to all Prof. Thompson's MWCC lectures. And let me just put that up here. And now, oops, it's called new page. Let me put this up at the top and give it a good name. There we go. And of course I have to copy that because there's two sections in this class, so I'll come to the other section here. Come to the course content, new blank page. YouTube lectures, paste it in there. And so you have access to everything coming across. I just wanted to make everything in there. So people have been asking me about dates and times and stuff, and I've been trying to answer through the announcements coming on Blackboard, and I've been trying to put up material that we can see things coming across and trying to respond to the emails. So the examples are going up. Now the examples are coming from, let me get back here so I can see this, and let me put that back up. All right. And so the examples are coming from questions that people have had on homework, and they're also coming from the review quizzes. So right now on Pearson, you have the homework that is due that takes us through the end of Chapter 4. And then there are two quizzes, one for Chapter 3 and one for Chapter 4, that would have been the same as the in-class worksheets. And then you will have due on April 12th an online exam that combines the material from those two worksheets, targeting on the things we need to focus on. All right, so that's where everything is up there. If you have any questions, continue to ask an email. Please, this is very imperative. When you ask a question in email, there are two things I need. I need the problem you are actually looking at. I get a lot of people that they'll say problem 5. But they're on homework 3 or they're on homework 6, or so I don't know what problem 5 is. In the upper right hand corner on Pearson, it will say the chapter number, the section number, and the problem number. And so we're just in Chapter 4. You could say 4.2.5 would be Chapter 4, Section 2, problem number 5. Or in Pearson, up in the upper right hand corner, there's a menu and there's an email my instructor, and it will send me the problem with the numbers you have. Because Pearson randomizes the numbers, everyone gets has a chance of getting different numbers. If you send me that using that link, I will get the exact problem you have. And what I'll do is I'll create videos for those. If you're showing me your written out work with like a photo on the phone, try to see if you can read it. I'm getting a few pieces of paper. I have one person in one of my other classes that their phone, for some reason, when they attach it to an email, I just get this, like, it's almost like every pixel on the camera is turned into a line. It's a very, very long line, but about the size of a picture in data size, but it doesn't come together as a picture. And I have a couple other people that they're taking me pictures of their pages. Some of them I can read really, really well. Others I can't see what's on their page. So try to see if you can open it up email it to yourself, look at it on the computer, and see if it's visible. I know I have a problem right now with my camera being able to focus in on the calculator screens, and I'm working on that. And I might just do all the calculator screen stuff on my phone. And sorry, I bumped my pop filter there a bit, if you hear that. All right, so today in this, Bill Shoemaker just asked, will the Chapter 3 homework allowed to be saved? And it should be savable. Let me look on that. All the homework should say save. What you have to do, and we found this out in my 162 class, is if you don't submit anything and the due date comes up, it will reset everything when you go back to do it. If you submit at one point before the due date comes up, it will allow you to go back with the same questions. I did not know that, and I cannot find a setting that overrides that. So the best thing I can say is do the first question, submit the homework, and then go back to it to improve the score. And that should take care of it resetting when it hits the due date. All right. And I hope that answered your question, Bill. I think that's what it might be related to. Though all of my copies with all of my homeworks do allow saving and allowing students to resubmit them. The quizzes, Chapter 3 and Chapter 4, I did choose to allow being saved on. The exam will not allow being saved. It is timed, but I do allow multiple attempts on the exam, 2 attempts right now. If we have any problems with that, we'll adapt it because we have to be flexible. All right, Cheryl asked what was the problem with Pearson. The problem with Pearson is they had an outage. They have a system status page, and they had an outage. It was requiring navigation to some of their course content to not work. I could get in perfectly fine. I talked to Festus and Tom Valletta, and so they had problems accessing it. Happened around 4 p.m. yesterday, and it's actually still happening right now, but not as major as it was. And none of the courses or none of the students I have seen are having that problem. It should be better. But if you have any problems, send me the error message and let me know. So Jay asked when I'll post the examples for Chapter 4. I'm recording them right now. I was posting them as I went last night. I should be done with them by the end of tonight. Remember, the due date on that test is, and the Chapter 4 stuff is the 12th. Right? So I'm giving a week to play catch up while we're working on the newer material coming across. All right, I got the questions coming through. I'm going to start looking at Chapter 5. Again, Pearson's problem was on Pearson's end. I sent the announcement by anyone that emailed me. I said as soon as I heard from Pearson, I would send an announcement. So I sent the blank announcement from Pearson across all of my classes, and so that's what you should see in the announcements is Pearson's statement on what's happening. They're continuing to work on it, but I think access is back for everyone. There might be some small bugs in the navigation. They updated their Excel component, which kind of links things together in the background. The Chapter 4 homework is due the 5th. That seems about right. That would have been Sunday. We had finished Chapter 4 at the end. If I push it to the 12th, everything's due the 12th. I can push it out. Remember, homework due dates don't matter as much. It's usually when I'm done talking about the material. And we have finished Chapter 4. So the homework for it is due. I would look at the 12th as being everything on Chapter 3 and Chapter 4 you want wrapped up, because that's when the completing the exam is due. So I would aspire to having it done by the 5th. But you know I don't take points off on the homework if it's late. So that's answering Jay's question on that. And Cheryl, so the chapter 3 and 4 stuff due on the 12th? Yes, chapter 3 and 4 stuff is due on the 12th. I think the quiz for chapter 3 is due on the 5th because we covered chapter 3 before we left on break. So I think that one is due this week, and then in next week the chapter 4 and the exam on the two things are due. So. All right. If you have any other questions on the admin stuff, just email me. I'm kind of finding it odd just leaving the crazy face on the screen right now, so I'm going to want to change things a bit here. And what we're going to do is I'm going to look at the PowerPoints here, and a lot of this has to do with just graphing. And this is something in the classroom layout. I'm looking for a way to put graphs up in the classroom setting where it is. Where the projector was falling right in the middle of the blackboard, and I actually couldn't write stuff off on the side, how I had done it in previous. The Lecture 5 slides are up on Blackboard. Both of them are up there. They should be. Now I have questions coming through, so let me just double check here. Course content. Yep, Lecture 5 is in Section 2. And also in... Yep, Chapter 5 is up on both sections, so they are posted there. All right, come back. All right, and Cheryl, I don't know what you want sent to you when you say send it to me. So please send me emails on this. I'm going to get started with the Chapter 5 stuff. All right, so and what we're looking at here is we're going to be looking at a normal distribution and the standard normal distribution. We're going to look how we find probabilities out of that, how we find the values, and we're going to look at sampling distributions and the central limit theorem. We're also going to look at binomial distributions and how they relate to the normal. Now, Chapter 4 was all about discrete distributions where our variable was countable. The normal distribution arises from continuous variables that can be subdivided. All of the ideas that we had with a discrete probability distribution comes across into these continuous probability distributions. The idea of how we figure out how much the probability has to do with the area under the curves. And so a lot of this is going to work with graphing, and graphs will define what we look at. So if I pull back here, and an idea that we generally have is if I have an axis, and so I'll make my axis here, and I have a histogram that I have generated where I'm counting the number of things that are in my discrete probability distribution. And I'm not going to make my graph too huge here. What we said was if I add up all the probabilities for each of my variables, I would get 1. And so this was whatever was in this bin was one of my variables. This was the next, and so on. And so I had all the variables that could lie within this frequency distribution, or my countable numbers in this case, where I have these countable numbers for this discrete probability. If for some reason I started to make this get smaller and smaller and smaller. So it is like bins. And I'm looking at a range of numbers like we did in chapter 2 when we were building frequency distributions. I could make those bins arbitrarily small. And I could count the number of things that lie within that graph. So let me make another graph here. Move this up just a bit. All right, and we'll make my other graph here. And if my size of these bins got infinitely small, I would have an infinite amount of bins coming together, and I would get a curve. I wouldn't have any thick rectangles in there, but I could imagine it being filled with loads of little rectangles. I could fill it with loads of little rectangles. And if I added up the probability in all those rectangles, all those little probabilities, oops, I would still get 1. Well, if the rectangles are small enough, they would be creating the area under the curve. And in fact, that's the entire process of integral calculus, is finding areas under curves. And what we're able to do is we're able to use those results from calculus to figure out how much area is under the curve, or that the total area should be 1. And so we're going to take apart these graphs and look at what we can translate back and forth. Luckily, a lot of this work has been done for us by other mathematicians. And so we want to find, as it says here, the areas under the standard normal curve. Notice if the total area adds up to 1, that's 100% probable. So anything probable is happening within our curve or within our graph. That was a limit we had on discrete probability distributions, that every possibility had to be played out. Same thing's going to happen with continuous, that within the range of my continuous variables, I'm guaranteed something happens. Where it happens, the probability distribution finds out. And the probability distribution we're going to look at is called the normal distribution. So if we look at the normal distribution, it has a continuous random variable. And what we're doing here is we're looking back at the time the agent spent on the phone. Remember how we said, well, that's a continuous variable? And so we have a random variable that we can look at any possible value between 0 and 24. It has definite endpoints, but I could look at 9.1 hours. I could look at 9.12 hours. I could look at 9.13, and smaller intervals as it went by. Now what happens is we get this curve called a normal distribution. And here is the normal probability curve. And if we look at the normal probability curve, there are some properties about it that can help us out. And so when we look at this curve, and you're going to see as I try to move my mouse across it here that I can highlight some things. So first, it starts by it's curving up. At some point, it starts to curve down. All right, so if I'm moving from the left side over here, it's curving up, and at some point it curves down. And that point where it changes direction is called an inflection point. And it's an important measure on this curve. Now, this is a continuous probability distribution for a random variable. If I randomly choose things, there is some middle that variable is going to be around, and then it doesn't quite always hit that middle value. And so the normal curve has that middle, which is going to be our mean. Missing that middle value is related to the error in the randomness coming across. And so we're going to look at all the properties that come from the shape. And I want to, when they say it's the most important continuous probability distribution in statistics, that's an understatement. You can do all of statistics for up until you get into very, very specialized methodologies using just normal curves. And you will see with the central limit theorem, even if the data isn't truly normalized, the randomness can help you infer things from it. So, oops, let me come back here. And so, if we look at the properties of it, the mean, median, and mode are equal. This middle ground has exactly equal amounts of stuff on either side. So the mean and the median end up in the same place. And how high the curve is, how tall it comes up from the axis, tells you how many things are there. And so the tallest point is straight down the middle, and so that makes the mode. It has different names. A lot of people might have heard it as being called the bell curve because it has a bell-like shape. The normal curve, in fact, the idea of normalcy comes from how you come around a mean to a central approach. It's also called a Gaussian, from Gauss, Gauss, who studied a lot of the techniques in calculus that helped us calculate the areas of these things. So the total area under the curve is 1. And so in the terms of our probability, that means that my answers, my probability of success, is 100%. Something is going to be under the curve. Just where in the probabilities are determined by the height of the areas I'm looking at. It never touches the x-axis. It goes on forever. In physics, we use this a lot, is we have an infinite universe, something happens somewhere. And then you look, where is it centered? Well, and that's when we say something is happening locally, right? It's happening where that mean is. But there's always a chance that the event can be happening far away. Of course, the height gets smaller and smaller and smaller. And we're going to see that the height of the curve, how high we are looking at one point, talks about the probability that we can see of an event happening within that area of measure. Now, our friend the standard deviation comes back. And if we look at the inflection points touch at exactly 1 standard deviation on either side of the curve. So this inflection point on the left here and this inflection point on the right are within 1 standard deviation on either side of the mean. And we talked about that when we were looking at standard deviations, and we were looking at z-scores and how we moved a standard deviation away from a mean. And so the points at which the curve changes from sloping up or down is called the inflection point. And in a standard normal curve, they are 1 standard deviation on either side of the mean. Now, any probability density function that's discrete can be graphed with a histogram. All the things that we did before, so I'll go back here to show, right? Here's a discrete probability density function, right? And it's a histogram with everything in bins when you have countable things in bins. But if I'm working my way towards an infinite subject or something that could represent a larger, the continuous probability distribution we use a PDF. A probability density function has two requirements. The area under the curve has to be 1, which we have in the normal, and the function that defines it can never be negative, because that would require that we have a negative probability. Sorry for the change in volume there. I moved some stuff around. All right. And so these things play out. Our values play out, and we get an idea, heading up here, of our normal distribution. And so our normal distribution is going to be a probability distribution function that has the area under the curve as 1 and is always above the x-axis. And here we have 3 different standard deviations, or 3 different normal curves with different standard deviations and different means. And so we want to look at how these numbers affect what our curve does. Again, underneath all of this, this still adds up to 1 for each of these curves, but the measure that we've been using, and we've used these 2 numbers before, the mean and the standard deviation, are going to tie back to our chances of finding values. And so here, this first one has a mean of 3.5, while the second one also has a mean of 3.5. The first one has a larger standard distribution. Again, repeating stuff we did in chapter 2 when we observed this and measured it. But now this stuff is happening randomly. And so these 2 concepts are coming back together. And there's a little redundancy from what we've done in chapter 2. Okay, yes, the slides are on Blackboard. They're under lecture 5. Come across. And so the smaller the standard deviation, the more narrow the data is. And then the mean is where it's centered. And so in these 3 graphs, we have the left and the right graph have the same mean, but a different standard deviation. And the center and the right graph have the same standard deviation, but different means. And so we can see how a normal distribution moves and how the normal distribution moves across. The PowerPoint is corrupted. Okay, I will re-upload it. Coming through. It's telling you to download the PDF. All right, I will look into that when I am out of here. It is using. Let me save this here. Save as. I will enforce it to be. I see. It used a weird format. The PDF is fine. Okay. Thanks, Bill. I will work on getting an uncorrupted part after the PDF comes through. It is the exact same one I'm using here. So, the fact that it's viewable here and not there, and they were created in Microsoft to start with. Okay, so let's look at a probability distribution function and how they come out, specifically a normal one. And so these are scaled scores from a New York Common Core mathematics test, and it's normally distributed. The normal curve represents this distribution. What is the mean score? Well, the mean will fall about the middle point here. And so we have 280 to 330 on either side here. So probably 315-ish, right? Right around here is where the middle is. And the standard deviation is where these inflection points come about. So it looks like I'm inflecting about here. So you see how visually, and I'm trying to point down. Did I leave this on the point? All right. Yep. My cursor should be moving. You should see the cursor move. I try to move the cursor, has a way of showing, and you should see the cursor come down through there. Does it come across? No. Okay, let me move this normal curve over to here. Hold on 2 seconds. Trying to paste the image over. 305 is the mean. Okay, yeah, roughly. You've got the PowerPoint. Well, I will drop down to the next slide while I try to draw this. And so, if we draw that middle line down, it's at 305, which is halfway in between the 2 points. And then if we look for the inflection point, we find the points where they meet, and so it's about 40 off. So it's at about 265 and 345 where these inflection points are. And these are the things we want to look for in normal curves, is where the center is and where the inflection points are. Trying to get my on-screen helpers to work here, and every time I put them on, they move the images around. Well, remember the empirical rule from chapter 2. The area under the curve between those two inflection points is 68%. If we go out another standard deviation to 265 and 345, we keep going out by, between 265 and 345, between one standard deviation on either side is 68% of the data. If we go out another standard deviation, another 40, we get 225 and 385. And if we continue out one more standard deviation, we get 185 and 425. So Jay, are you asking how to find the points? So I'm typing back to Jay there on asking how to find the means and the points. Let me draw one here. All right, so if we come over and look at any normal curve, and I'm just drawing one here, it will have a middle. And so you eye where the middle is and come straight down. Where that number is on the graph is going to be the mean. The other part is this curve changes direction, and that you get used to where the wide ones come across. That's +1 standard deviation and -1 standard deviation. When the graphs have good measures on them, these are fairly easy to estimate. So if I come back here, but what you're hunting is these points. So those inflection points. Now, eyeing up the inflection point is fairly hard. And I'm not going to ask you, hey, here's a graph. Where is 1 standard deviation? Where is 2 standard deviations? We'll tend to go in the other way. You'll have a standard deviation or you'll have a point. And from that point, we can calculate how much area is under the curve. But the concept should be visually there. And when you see normal curves, if you kind of look at those inflection points, they're a little above in height, the halfway point. In fact, they're roughly around 60-some% up. And so I kind of look at the height here, and then I kind of come down about a little more than a third, and I hunt the inflection point there. Again, this is an estimate. We will be calculating with much more accuracy. But when someone's giving you graphical information, you can look at the graph, go, okay, the mean's in the middle. That's the average value. And one standard deviation is about so much. Well, my empirical rule is going to tell me then how much percentage is in there. And this is what we covered in chapter 2 when we observed data. Now, if things randomly fall into this means we can also infer from the data from it. And so for any standard normal distribution, we can go back to what we did at the end of chapter 2, which is we can find a z-score. And so a normal distribution that we place the mean at 0. And so we're calling this a standard normal deviation. We place the mean at 0. Then we can make a z-score where we take the value minus the mean and we divide it by the standard deviation. And that tells us where we are at in the curve. And what's going to amazingly happen with this, if I come back to my picture here, and we were doing this with z-scores before. If everything in between -1 and +1 standard deviation is 68%, then I have 34% here and 34% here on either side of my mean. Okay, there's my mean. I've got 34% of my data here and 34% of my data here. I've got 16% here and 16% here. I'm actually giving you calculations of areas under the curve. By knowing these positions relative to the standard deviation, we're going to be able to figure out our probabilities. So all the stuff we developed at the end of chapter 2 comes back, and we can start talking about, hey, what happens if I have this chunk of stuff? What is my area under the curve for that chunk? And it all relates back to this measuring percentages under the curve. We can do that if we create a standard normal distribution. We create a distribution that we can put off of 0 and we can calculate all of the values out of it. Then we can compare any normal distribution to that standard. And so our standard normal distribution has a mean of 0 and a standard deviation of 1. This is our comparison curve. We're going to use this to compare any other curve that we have out. And so the idea of standard normal distribution, hey, let's compare it to anything else we can create. Well, if we look at all the area that is underneath the curve, even though these are infinite, when we get around a z-score of -3.9, if we start on the left-hand side here, we can say that the area underneath that is close to 0. And then as we get all the way out to the right-hand side, we get to 100%. I want to come back to my drawing here, and I'm going to draw another one down below and talk about this cumulative property. So I'm going to draw my first axis here. And draw my second axis here. And so I am centering around 0. So I'm going to draw my 0 line here. That line's at 0. So I have a normal curve that comes down and goes off. And that should be the highest point there. It comes down and goes off. I apologize, my curvature is not quite. And so because we made it have a standard deviation of 1, that's at positive 1, and that's at negative 1. By making the standard deviation 1, we've created definite points on this curve that line up. Now, if I'm over here at negative 3.49, this is so close to 0 that we say the area under the curve is 0. Well, if the area under the curve is my probability, I start off here at negative 3.9 with 0% chance. As I move to the right and I reach my mean, well, that's 50% of my stuff is over here. So I start with 0% of my stuff, and as I work my way through and it adds up and adds up, and I'm adding up every little bit under the curve, when I get to my mean, I've gotten to 50% of it. Well, as I continue over here, as I get to positive 3.49, approximately 100% of the stuff is there. And so we will tend to say that between negative 3.49 and positive 3.9 for the z-scores. So between negative 3.49 and positive 3.49 is almost 100% of the stuff. Now, it's funny in the type of sciences I do, and you'll sometimes hear even in businesses they'll talk about a thing called 6 sigma, and in physics we deal with 5 sigma, which are standard deviations, is that we want the data to be accurate to 5 standard deviations. And so we're talking about a very, very precise level of percentage of the data being there. We want our error to be less than thousandths of a percent. And 6 sigma in business, you want a high precision quality. But in all points, the probabilities after 3.5 standard deviations are close to having everything there. And so, and we'll get the other side as the area gets close to 1 at 3.49. And so the standard normal curve takes all, by having the standard deviation at 1 and the mean at 0, it has a way of relating the z-score to the probability and the area under the curve, which means that we can then use a z-score as a measure for any data we get. So we take the standard, we calculate the area. Whoops, that was me hitting my microphone as I waved my hands about. We calculate the area under the curve, and we write it down in a table. And here is how a table comes together to show us a z-score. And so what happens is that we have tables in the book, and I'll get back to them. They're also in the handouts that come out in the front of the book. And I will print those out and put those in PDF also on Blackboard. But notice in the corner of this one, it has a normalized curve. We have some data, and it has a blue part colored in. And so our table will talk about, there will be a left side and a right side of the standard normal distribution. And so when you look at the table, you're going to want to see which side is colored in. For ours, there are 2 tables. They're table 4 in the appendix of the book. Let me see if I can get these in here. Hello. All right. Let me, sorry, as I swing this around, the dizzy time. All right. So there is table 4 in the book. Okay. It's an appendix A16. Now I'm going to go back to, but notice up here, this is talking about, we're looking to all the area to the left of a value. It's the part colored in. We look at the second part of this table, and it has all the area to the left of a value over here. And again, it's the part that's covered in. So when we use these tables, we have to look at what part we're looking at. All right, I'm going to switch back here so I don't do the dizzying thing with the graphics. And that's what this slide is trying to show. So it's trying to show that table. What I'm going to do is I'm going to draw out, because the thing you want to do when you have some probability is you want to figure out the area under the curve to use the table. And so what this example is trying to show for you here is, look, my thing copied down just in the wrong place. But let me scroll down below this a bit here. Oops, here we go. All right, so they're saying that we have a standard normal curve. No, sorry, my right hand sides are always a little squishier. Let's try this here. I will definitely get a good standard normal curve drawn and then maybe copy it and do these much better on the blackboard. And we're looking at how much probability or how much stuff has come before a z-score of 1.15. So if this is my mean and my z-score is equal to 1.15, well, that's a positive score. So I'm over here. There's my 1. I'm over here somewhere. That's 1.15. And so I start off with 0. I work my way until I have 50% under the curve, and I keep going until I hit my 1.15. Well, that has some area under the curve, or some probability, or some percentage of stuff up to that point. And that's what the table does. So I'm going to come back to the table here, and we want to look up the value that comes from the table. So as we come to the table, we want to find 1.15. Now it's positive. All positive scores will be on the right of this, the right of your mean, right of 0. All negative scores will be to the left, and that's why there's two different tables. There's the negative scores and the positive scores. Because this is a positive 1.5, I come down until I find 1.1. I find the first two numbers, the number before the decimal place and the number just after the decimal place. And then you come down to 1.1, and you need to find the third digit, which is up top here. It's the 0.5. If I add 0.05 to 1.1, I get the 1.15. So I go across my row until I get to that number. And it tells me that the area under the curve is going to be 0.8749. And so that's how we start using these tables to look up the scores. Now, so the answer for a z-score of 1.15 is 0.8749. These are in the pullouts. There are two tables, one for the left side of the graph and one for the right side of the graph. They're table 4. They're also in the appendix of the book itself. So the normal distribution is so used that it's both in the fold out and it's also in the book in the back. And I will get a copy of the fold out up there. This is calculable also on the TI-84s. And what I want to do here is now lower, upper, So I apologize. I was turning on mine. In the corner here, it shows the TI-84 and it says normal CDF. Now on your TI-84, I'm going to try this again without getting too dizzy. Normal. We're going to do normal CDF. All right. So again, the screen's a little hard to read there, but if we hit the second key and the distribution key, you're going to get an option. Second distribution, you get an option for normal PDF and normal CDF. What CDF is saying is cumulative distribution function. All right, and I'm going to go back to this scene now. I'll go through. And so what the calculator is going to ask you for is the lower limit, except the number it has in there. It will tell you -1 e to the 99th. And then it'll ask you for the upper limit, which is the 1.15. It's where you're looking towards. Then you're going to put the mean at 0 and the standard deviation at 1, which are all the defaults for you. And you put that in, and it's going to spit out the number you see there. And the TI-84s do that nicely. The TI-30s don't, so you will need to use the tables in the book if you have a TI-30. And that's a difference on the technology there. But notice that this is a cumulative distribution function. It is talking about the total area up to, cumulatively, to the point that we're looking at. And if we look at a negative z-score, so in this case, a z-score of -0.24, so I'll come back here, and I'll draw this in purple over top of the blue. So -2.4 is going to be on that side of the mean, because if the mean is 0, negative numbers are to the left. And so z-score of -2.4 is going to put you here. And we want the cumulative value all the way up to this, or the area under there. And it's a cumulative positive area. All areas are always positive, even though the z-scores can be negative. And so we have -0.24. On the table, we need to find the first two numbers, 0.2. Notice the negative scores run upwards, right? And so we come to -0.2 and then over to the 0.04. And down to the 0.0452. So notice on the table, the -0.2 and the 0.04, we find where this row meets this column, and that spells out what we have for the z-score, and we get 0.0452, or roughly 40% of the stuff lies before that z-score. And that's how we find the percentage value up to a point. Now I'm going to stop here, and we're going to continue on, because what we're going to end up doing is we're going to find the ability to find any area between any two values that we have. But we're going to look at this. We're going to leave it here with looking at the tables. Okay, I want to make sure that I can get the PowerPoint up there corrected for you. I'm going to make sure that I get a copy of the fold-out that's in the textbook up on Blackboard. Outside of that, we'll be using the tables in the back of the book. And if you have a TI-84, it has the CDF functions on them, and I would get used to using the CDFs. So if you have the TI-30 XIISs, we have to use the tables with those. If you have the TI-84s, it spits out the value. It's the exact same value you'll get from the table. It's just a question of where you're going to get it, from the table or from the calculator coming across. And our goal is going to be able to calculate this standard z-score onto any given data coming through. So our goal is this week is to finish chapter 3 and 4 and get to the point where you're comfortable with the material to start taking the exam. While we're doing that, we're going to be talking about chapter 5. But that's where we would have been if we would have come back for the exam, because I would have started lecturing on chapter 5 the week before we did the exam. So we're in about the same place. I'm going to post everything up on Blackboard. And again, I'm fixing the PowerPoints and getting the previews for chapter 4. I will get the chapter 5 homework set up. That'll be due April 19th-ish. So we're going to be doing some back and forth here. Keep sending in the questions coming across. All due dates are in the Pearson itself for the assignments. So log into Pearson, see what the due dates are. They're also on Blackboard in those chapter 3, 4, and chapter 5 sections. All right, that's all I have for today. 10 minutes left in class. Not too bad. I'll try to make the videos a little more smoother. If you need anything, email me.